Bismillahirrahmanirrahim. Today's topic is functions and limit exercise 1.5, and we are going to solve question number 2 part 3 and question number 4 part 2 and 3. Question number 2 part 3, we are given two parametric equations, x equals to secant theta and y equals to tan theta, and we have to draw its graph. So first of all we start making the table. For the table, we have three columns, theta, x, and y. We're going to give values to theta at the gap of 30 degrees, and correspondingly we will write the values of secant theta and tan theta. Here you can see x equals to 0, theta equals to 0 degrees, correspondingly secant is 1 and tan is 0, and so on. We are going to continue writing these values at theta equals to 30 degrees, the values of secant and tan, then 60 degrees, then 90 degrees. At 90, both of these have got two values, so we write both of these values with the help of these brackets, and you can see we are approximating the values to one place of decimal so that we may be able to draw them on the graph paper quite easily. Next we have got 120 and then 150 and then 180, 210, 240, 270, and then 300, and then 330, 360 is the last value. We write all the values of theta from 0 to 360 degrees at a gap of 30 degrees. Correspondingly, we get the values of secant theta and we write the values of tan theta. What is our observation? That we have got repeated values. X is 1 here, x is minus 1 here, x is 1 again here, 1.5 and minus 1.5 again, minus 1.5 and minus 1.5 again, and same is the observation here that the values are repeated. So we are going to rearrange this table. The role of theta is over here. The role of theta was just to give us the values of x and y. So now we are going to make a table again, rewrite our table again for x and y in a ways in which we will be able to plot the values easily. So let's see. At x, these are the values of x and y. At x equals to minus infinite, you can see the values of y is plus minus infinite. At minus 2, x is minus 1.7 and x is 1.7. At x equals to minus 1.2, here it is, the values of y are minus 0.577 and plus 0.577. At x equals to minus 1, we have value 0. At x equals to 1, we have again value 0. At x equals to 1.2, here it is, the value is minus 0.577 and the value is 0.577. And then at x equals to 2, the value is 1.7 and the value is minus 1.7. And then at x equals to infinite, you may write plus minus infinite. So we have got the values of x and y, and now we are going to plot these values on the graph paper. The graph paper, we draw x-axis and y-axis. You may write an x and x dash here. You may write a y and y dash here. The scale which we have taken on both axes is one small scale equals to 0.1. So let's mark some values on x-axis. This is 0, this will be 1, this is 1.2, and this is 2, this is minus 1, this is minus 1.2 and minus 2. Just count small squares, and after 10 small squares you can mark 1, after 10 small squares you can mark 2, and so on. Similarly, on the y-axis, you can see this is 0, after 6 small squares 0.6, 10 small squares 1, again after further 7 small squares 1.7, and further 3 small squares this is 2. Similarly, you can mark these points on negative y-axis. Let's start plotting the values. At x equals to minus 1, y is 0. At x equals to 1, y is also 0. So let's start with these. This is x equals to 1, y is 0. This will be the point. X equals to minus 1, 0. Y is 0. This will be the point. You can see. Next, at x equals to minus 1.2, the values are plus minus 0.6. At x equals to 1.2, the values are plus minus 0.6. So this is minus 1.2. This is 0.6. Mark it here. Minus 1.2, this is minus 0.6. Mark it here. This is 1.2, this is 0.6. Mark it here. This is 1.2, this is minus 0.6. Mark it here. Then At x equals to minus 2 and x equals to 2, the values are plus minus 1.7. So minus 2, this is 1 and 7 more squares, 1.7, mark it here. This is minus 1 and 7 more squares, minus 1.7. You will mark it here. At 2, this is minus 1.7 and this is 1.7, and here are the. Then take your pen and pencil, join these points by a free drawing of a smooth curve, and you will get the graph. For the finishing touch, you may put arrowheads here. Okay. So this, you may put arrowheads here, 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 and here, and finished graph. And this shape is called hyperbola. Let's get to our next question. Question number 4, part 2. What is the question? We have to solve graphically. X by 2 is equal to cos x. Let x by 2 equals to y1 and cos x equals to y2. Let's start making our table. This is going to be our x and this will serve as y1. This will be our x and this will be y2. You can see we have taken the values of x in degrees at a gap of 30 degrees from minus 90 to plus 90. Then we divide all these by 2 and then we convert them to the radians. So these, and you can see we have approximated the values to one place of decimal. So these are the values of x and these are the values of y1. Then again the same values of x, x equals to minus 90 to plus 90 at a gap of 30 degrees, and then we take cos at all these degrees and we get the values of y2, and you can see we have approximated the values to one place of decimal here too. So these are the values of x and these are the values of y. Now let's get to our graph paper. We have drawn x-axis and y-axis. Let's take the scale on these. The scale on x-axis is 5 small scale equals to 30 degrees, and on y-axis it is 1 small scale equals to 0.1. So what we will do, we will mark it as 0, and then after counting small scales 1, 2, 3, 4, we are going to mark 1 here, we are going to mark minus 1 here, and on y-axis, x-axis we're going to mark minus 30 after 5 small scales, minus 60 after 5 small scale, minus 90, and so on. You can see it there. The points are marked on x-axis. This is minus 0.3, minus 0.5, minus 0.8, minus 1. This will be 0.3, 0.5, 0.8, and 1. On x-axis is minus 90, minus 60, minus 30, 0, 30, 60, and 90. And now we start plotting these values. We are going to plot these values. At x equals to minus 90, the value of y1 is minus 0.8. Minus 90, the value is minus 0.8. Here it is. At minus 60, the value is minus 0.5. Here it is. At minus 30, the value is minus 0.3. Here it will be. At x equals to 0, y1 is 0. At 30, the value is 0.3. It will be here. At 60, the value is 0.5. It will be here. At 90, the value is 0.8. So it will be here. We mark it and then we join all these points by a straight line. Okay girls, now we have to plot x equals to y2. For that we get x equals to minus 90, y is 0. Here it is. At x equals to minus 60, y is 0.5. You will mark it here. At x equals to minus 30, y is minus 0.9, y is 0.9. So we will mark it here. At x equals to 0, y is 1. At x equals to 30, the value is 0.9. At x equals to 60, the value is 0.5. At x equals to 90, the value is 0. And then we mark these points and let's see what do we get. Now join all these points by a smooth curve and you will get the graph of x equals to cos x. This one is missing. You will have to put this mark by yourself. Now our original question was to solve the equation. So solve this equation, we need the point of intersection of the two curves. So just mark this point of intersection and draw a vertical line till x-axis. X equals to 60 degrees. It will give you the answer of the solution of this equation. X equals to x by 2 equals to cos x. So girls, if graph by a computer program, this is the graph which you are going to get. You can see here the point of intersection is a bit less than 60 degrees. It is approximately 58 or 59 degrees. So we have got 60 degrees. That is good enough for us. That the solution is complete over there. This is just for an extra information. Test number 4, part 3, 2x equals to 10x. So by using the same strategy, let 2x equals to y1 and 10x equals to y2. This is our x, this is our y, this is our y1, this is our x, and this is our y2. We take x in degrees from minus 90 to plus 90 at a gap of 30 degrees. Then we multiply all these by 2 and then we convert them all into radians and we approximate the values. On the second table, that is for x equals to y2, which is tan x, we take the angles from minus 90 to 90 at a gap of 30 degrees and then we take tan of all those values and these are the values which we get, and you can see we approximate the values. Let's get to the graph paper. X-axis, the scale is on x-axis is 5 small scale equal to 30 degrees, on y-axis is 1 small scale equals to 0.1. These are the marks on x-axis, y-axis, and we are going to start plotting our graph. First of all, we are going to plot these values. Forget about minus 90 equals to minus 3 because you can see I haven't marked minus 3 on my graph paper, so I'm not going to plot this particular point. I'm going to start plotting from minus 60. At minus 60, the value is minus 2. Minus 60, the value is minus 2. At minus 30, the value is minus 1. So at minus 30, I will mark here. At 0, I will mark 0. At 30, I will mark 1. At 60, I will mark 2. These are all my. I will join all these points with the help of the graph of x equals to y1, which is 2x radian. Let's get to the second graph, x equals to y2. The values to be plotted are minus 98 it has got the value minus infinite, forget about it. Let's start from minus 60. At minus 60, tan is minus 1.7. So minus 60, the value is minus 1.7. Here it is. At minus 30, the value is minus 0.6. It will be here. At 0, it is 0. At 30, it is 0.6. At 60, it is again 1.7. Mark all these points, join these points with a free hand drawing of as a smooth. This is the graph. And what is the next step? We have to find the solution. So mark this intersecting point and draw a vertical line till x-axis. Mark this intersecting point and draw a vertical line till x-axis, and also this point 0. This is also an intersecting point. So what do we see? We have got three solutions. One solution is minus 64 degrees because this line touches the x-axis at approximately minus 64. This solution is 0 degrees and this solution is 64 degrees. So we have got these three values as the answer of this, as a solution set of this given equation. And that completes the solution.